For decades, Boeing and Airbus have dominated the skies. Together, they control over 90% of the global long-haul aircraft market. But something just happened that could change aviation history. China's brand new C929 wide-body aircraft has reportedly completed a massive 12,000-kilometer test flight, a distance that places it directly in competition with the world's most advanced long-range jets. And this isn't just another prototype. The C929 represents China's boldest attempt yet to break Western dominance in commercial aviation, a sector worth hundreds of billions of dollars annually. If China succeeds, airlines across Asia, Africa, and even parts of Europe could soon face a new choice: buy American, buy European, or buy Chinese. So the real question is this the beginning of a new aviation superpower? Let's break it down. The C929 is China's first domestically developed wide-body passenger jet, designed to compete directly with aircraft like the Boeing 787 Dreamliner and Airbus A350. Unlike China's smaller C919 narrow-body jet, the C929 targets the long-haul international market, the most profitable segment in commercial aviation. The aircraft is being developed by CRAC, a joint venture between China's COMAC and Russia's United Aircraft Corporation. Originally, Russia was expected to play a major role in the project, but geopolitical tensions and sanctions have reportedly shifted most development responsibilities to China. That alone highlights how important the C929 is to Beijing. This isn't just about building a plane, it's about building independence from Western aerospace technology. The C929 is expected to carry between 250 and 320 passengers, depending on configuration. That places it directly between Boeing's 787 and the larger 777 models. Early design reports suggest the aircraft could achieve ranges of approximately 12,000 kilometers, allowing airlines to operate transcontinental routes such as Beijing to London or Shanghai to Sydney. One of the most important aspects of the C929 is its use of composite materials. Modern wide-body aircraft rely heavily on carbon fiber composites to reduce weight and improve fuel efficiency. Boeing introduced this concept widely with the 787 Dreamliner, and Airbus followed with the A350. China is now attempting to master this same technology, and if successful, it could dramatically improve China's aerospace manufacturing capabilities beyond just aviation. The aircraft is also expected to include modern cockpit avionics, advanced aerodynamics, and next-generation passenger cabin designs. Chinese manufacturers are reportedly working to create cabins comparable to Western standards, including improved air pressure, humidity control, and passenger comfort. But perhaps the biggest challenge for the C929 isn't engineering, it's trust. Airlines and regulators around the world will carefully examine safety certifications, reliability data, and long-term maintenance support before committing to such a major aircraft purchase. Still, the progress of the C929 signals something bigger than one airplane. It signals China's determination to become a full-scale competitor in one of the world's most technologically complex industries, and that could reshape the balance of power in global aviation. At first glance, a 12,000-kilometer test flight may sound like just another engineering milestone. But in aviation, range is everything, and this distance places the C929 firmly inside the most profitable and strategically important segment of global air travel. Long-haul routes generate massive revenue for airlines. Flights connecting major economic hubs like Beijing to London, Shanghai to Sydney, or Guangzhou to Dubai are among the most competitive and financially valuable routes in the world. These are routes traditionally dominated by aircraft like Boeing's 787 Dreamliner and Airbus's A350. By reaching the 12,000-kilometer range, the C929 is no longer positioned as a regional experiment. It becomes a true intercontinental aircraft capable of competing on routes that airlines rely on for their highest margins. For comparison, the Boeing 787-9 typically offers a range of about 14,000 kilometers, while the Airbus A350 can reach roughly 15,000 kilometers depending on configuration. While the C929 may still fall slightly behind Western aircraft in maximum range, the difference is smaller than many analysts expected. And in aviation economics, performance is only part of the equation. Cost is often the deciding factor. China's aviation industry benefits from strong government support, massive domestic supply chains, and lower manufacturing costs. If the C929 can be produced and sold at a significantly lower price than its Western competitors, it could become extremely attractive to airlines in emerging markets. Many carriers across Asia, Africa, and the Middle East are rapidly expanding but operate under tight financial constraints. For these airlines, saving tens of millions of dollars per aircraft could outweigh slightly lower performance numbers. Another strategic advantage is China's massive domestic aviation market. China is projected to become the world's largest air travel market within the next decade. That means Chinese airlines alone could provide enough demand to sustain early production of the C929, even before large international orders appear. This domestic support gives China something Boeing and Airbus rarely have, a guaranteed launch market backed by state influence and national strategic priorities. But perhaps the most important signal of the 12,000-kilometer test flight is psychological. It sends a clear message to the global aviation industry that China is no longer simply copying existing technology. It is now building aircraft capable of competing at the highest level of commercial aviation. And if airlines begin to see the C929 as a viable alternative, the competitive landscape could change faster than many Western manufacturers expect. In commercial aviation, technology wins headlines, but economics wins contracts. And this is where the C929 could become a serious threat to Boeing and Airbus. Wide-body aircraft are incredibly expensive. A single Boeing 787 Dreamliner typically lists for around $250 million, while Airbus A350 models can exceed $300 million depending on configuration. Airlines rarely pay full list price, but even with discounts, these aircraft represent enormous financial commitments. China appears to be targeting this exact weakness. Thanks to heavy government backing, state financing, and tightly controlled supply chains, Chinese manufacturers may be able to offer the C929 at significantly lower prices. If the aircraft enters the market even 15 to 20% cheaper than Western competitors, it could dramatically shift airline purchasing decisions, especially in fast-growing but cost-sensitive markets. Another advantage lies in financing flexibility. China has already demonstrated its ability to support large infrastructure projects globally through initiatives like international development loans and export financing programs. If similar financing structures are offered to airlines purchasing Chinese aircraft, it could create powerful incentives to choose the C929 over Western alternatives. Beyond pricing, China is also building something Boeing and Airbus have relied on for decades: a vertically integrated aerospace ecosystem. Western aircraft manufacturers depend on thousands of suppliers across multiple countries. This global network has historically improved efficiency, but it also creates vulnerabilities, as seen during recent supply chain disruptions and geopolitical tensions. China is attempting to localize much of this production. By manufacturing key components domestically, from composite materials to avionics and structural parts, China could reduce dependency on foreign suppliers while maintaining tighter control over production costs. Labor costs also play a role. Aerospace manufacturing requires highly skilled workers, but China benefits from a large and rapidly developing engineering workforce. Combined with government-supported research programs and university partnerships, this allows China to scale talent faster than many Western countries facing aging labor forces. Maintenance and operational costs could become another battlefield. Airlines don't just buy airplanes, they buy long-term service ecosystems. Boeing and Airbus generate enormous profits through maintenance contracts, spare parts, and technical support. If China offers competitive long-term maintenance packages bundled with aircraft sales, it could further disrupt traditional pricing models. However, price alone will not guarantee success. Airlines are extremely risk-sensitive, especially when introducing new aircraft into their fleets. Reliability, safety history, and global support infrastructure remain critical factors. But if China manages to combine lower costs with reliable performance, the C929 could force Boeing and Airbus into pricing pressure they haven't experienced in decades. And in a market where airlines constantly fight razor-thin margins, even small economic advantages can reshape global fleet decisions. Despite its technological progress and potential economic advantages, the C929 still faces enormous challenges before it can truly compete with Boeing and Airbus on the global stage. The biggest obstacle is certification. For any commercial aircraft to operate internationally, it must receive approval from major aviation regulators, including the US Federal Aviation Administration and the European Union Aviation Safety Agency. These certifications are among the strictest and most complex approval processes in the world, often requiring years of testing, safety validation, and operational data. Without Western certification, the C929 could face serious limitations. Airlines operating routes into North America and Europe typically require aircraft that meet FAA and European regulatory standards. If those certifications are delayed or denied, the aircraft's international reach could be restricted primarily to domestic Chinese routes and friendly partner countries. And certification is not purely technical, it is also deeply political. Relations between China and Western governments have grown increasingly complex, particularly in technology sectors considered strategically sensitive. Aviation, which involves advanced materials, software systems, and national security considerations, sits directly in that category. Sanctions and export restrictions could further complicate development. Many modern aircraft rely on specialized components such as engines, flight control systems, and high-end semiconductors. If China is unable to secure reliable domestic alternatives for these critical technologies, production timelines and performance targets could be affected. Another major challenge is global trust. Airlines base purchasing decisions on decades-long reliability records. Boeing and Airbus have built relationships with airlines, regulators, and maintenance providers over generations. Their aircraft are supported by massive global service networks capable of delivering spare parts, technical expertise, and emergency support anywhere in the world. China is still building this infrastructure. Airlines considering the C929 will ask difficult questions. How quickly can replacement parts be delivered? Will maintenance training be available globally? How reliable will long-term service support be? These logistical factors can influence purchasing decisions just as much as aircraft performance. Passenger perception also plays a subtle but important role. Commercial aviation depends heavily on public confidence. Even if the C929 meets safety standards, it may take years for passengers and airlines to fully trust a new aircraft platform from a relatively new manufacturer. However, China has demonstrated patience in strategic industries before. The country's high-speed rail network, for example, expanded rapidly after early skepticism and is now the largest and most advanced rail system in the world. The success of the C929 may ultimately depend not only on engineering, but on China's ability to prove long-term reliability, build global partnerships, and win the trust of airlines and passengers alike. The emergence of the C929 signals something much bigger than the launch of a new airplane. It represents a shift in the global balance of aerospace power. For decades, Boeing and Airbus operated in what was essentially a two-player market. Airlines had limited choices, pricing remained relatively stable, and technological leadership stayed concentrated in the West. But China's rapid progress suggests that era may be coming to an end. If the C929 proves reliable, affordable, and capable of securing international certification, airlines could soon gain a powerful new alternative. Increased competition could lower aircraft prices, accelerate innovation, and reshape airline fleet strategies worldwide. At the same time, the stakes are enormous. Commercial aviation is not just about transportation, it's about national prestige, technological leadership, and global economic influence. The success or failure of the C929 could determine whether China becomes a permanent third pillar in the aviation industry. One thing is already clear: the skies are becoming more competitive than ever before, and the next decade could redefine who truly controls global aviation. If you enjoy deep analysis of global technology, geopolitics, and the industries shaping our future, make sure to subscribe to the channel and hit the like button. It helps us continue creating detailed content like this. Thanks for watching, and we'll see you in the next video.